In this lesson, we'll show how to calculate forward and inverse cumulative distributions for Gaussian densities, and we'll demonstrate how to solve for an unknown mean or standard deviation from a Gaussian interval probability. Well, let's start with a Gaussian density with mean mu and standard deviation sigma with a density that's similar to the one that is shown here. The cumulative distribution at some threshold t is a probability that is defined by the area under the density up to that point. Now at this point we have four quantities that are related through this interval probability: the mean, the standard deviation, the threshold, and the corresponding probability. Now when we work with Gaussian interval probabilities, three of these quantities will be specified and we'll need to determine the fourth. Now the most common situation, and maybe the most straightforward, is when we specify the threshold, the mean, and the standard deviation, and we want to determine the probability. Now if we have a function that can evaluate the normal cumulative distribution function, as we do in MATLAB for instance, then we can use the function directly to evaluate the probability by specifying the threshold, the mean, and the standard deviation. Sometimes instead we'll have an error function available to us, and we can calculate the probability in this way. And if we have a complementary error function, we could use it like this. Now in all situations it's rather straightforward to find the probability from the other quantities. In some situations the unknown quantity will be the threshold. In this case we might have a function that can evaluate the inverse cumulative distribution function for a Gaussian random variable directly, and we would specify the probability, the mean, and the standard deviation. Or we might have an inverse error function that we would use in this way, or possibly the inverse complementary error function, which we'd use like this. Sometimes we'd be after the right tail probability, but because this is 1 minus the left tail probability, we could easily modify our approach for finding this probability. Or for finding the threshold by simply noting the relationship between the right and left tail probabilities. Now in some situations, it's possible that the mean will be the unknown quantity. Now here we'll make use of the fact that we'd have a standard normal random variable if we subtracted the mean and divided by the standard deviation. The normal distribution will have a different threshold for the specified probability, and we can find that by using the inverse cumulative distribution function for the standard normal distribution. This would give us the threshold that corresponds to the specified probability for the standard normal variable, and then we could use the relationship between the standard normal and the original random variables to solve for the unknown mean. And then we'd make a simple modification if we had the right-hand tail probability. Finally, we could have the situation where the standard deviation is the unknown quantity. In this case, we could use the same approach and solve for the unknown standard deviation instead of the mean. And again, we could make a simple modification to solve for the right-hand tail probability. Well, in summary, understanding how to solve for any of the related variables in a Gaussian interval probability is an important skill to develop in probability theory.